Okay, so as I said, we're going to look at the muscular system, and we're also going to look at its relation to exercise. So first of all, a little bit of recap from level 2. So can anybody tell me what the 3 types of muscle tissue are? Muscle tissue, there's 3 types. Three muscle tissue types. Anybody know what they are?
Is it smooth, muscular, and cardiac, possibly?
Yeah, so similar names that you've got. So the first one we're looking at is voluntary. So voluntary muscle is also known as skeletal or striated muscle. It's involved in exercise and it's under the conscious control of the nervous system. But what I mean by that is that we can control it. We decide to contract and relax voluntary muscle. Okay, so skeletal muscle, so obviously it's attached to the skeleton, and its characteristic is that it's striated. So it looks like it's got striations on it. You can kind of see the lines of muscle fibers on the muscle. The next one is involuntary. So involuntary muscle is also known as smooth muscle. It's found in places like the digestive tract and the artery walls. This is under the unconscious control of the nervous system. So we don't decide to contract or relax these muscles. So for example, in digestion, in the digestive system, we can't switch it off or switch it on again. Okay. And the final one is cardiac muscle. So cardiac muscle is striated. Okay, so we can see kind of the muscle fibers within the cardiac muscle within the heart. Okay, however, it is involuntary. We cannot switch it on, switch it off again. We can't decide to contract it or relax it. So it's under the unconscious control of the nervous system. So it's the specialist heart muscle. It's also known as the myocardium. So you might see that written somewhere where it's called the myocardium. Contraction of the heart is controlled by the sinoatrial node, which we mentioned earlier, and the set rhythm of the heart on average is about 72 beats per minute at rest, and this is called autorhythmicity. Okay, so 3 types of muscle tissue are voluntary muscle, involuntary muscle, and the cardiac muscle. So muscle structure looks a little bit like this. So we've got the bone. What attaches the muscle to the bone is a tendon. The outer layer of the muscle, so surrounding the whole muscle, we've got the epimysium. Inside the epimysium, we've got our bundles of muscle fibers. Each bundle of muscle fiber is also known as a fasciculi. The fasciculi are surrounded by a perimysium. Each perimysium then each bundle of muscle fiber then contains muscle fibers. Each muscle fiber, each individual muscle fiber is surrounded by an endomysium, and each muscle fiber then is made up of a myofibril. Okay, so to explain that in a bit more detail. So the bone. Body movements are controlled by the actions of muscles pulling on the bone. Bones are covered with periosteum onto which tendons are attached. So a tendon will attach to the perimysium of the bone. So the periosteum of the bone. So the periosteum is like a cling film that surrounds the bone. Okay, this is where the bone gets its blood supply and its nerve supply. But the tendon will also attach onto the periosteum of the bone. So the tendon itself is a tough, inelastic fiber that wrap around the end of the muscle and attach it to the outer layer of the bone. The epimysium, this is a tough membrane that surrounds the whole muscle belly and holds the smaller fasciculi units together. So the fasciculi units are the bundles of muscle fibers. The perimysium is the membrane that surrounds the bundles of muscle fibers called fasciculi. The endomysium is the membrane that surrounds the individual muscle fiber, which contains the myofibrils. Myofibril then is the smallest unit or fibril within the individual muscle fibers. The myofibril is made up of smaller units or chain-like lengths called sarcomeres, which are the working units of the muscle. Okay, so let's just jump back up to the diagram again. So we've got the bone. So the tendon attaches the muscle to the periosteum of the bone. Surrounding the whole muscle belly is called an epimysium. So this can also be called fascia. Okay, so fascia kind of links muscle to muscle, but it surrounds the whole of the muscle belly, the epimysium. Inside the epimysium, then, we have got our bundles of muscle fibers. Those bundles of muscle fibers are also called fasciculi. Each bundle of muscle fiber is surrounded in a perimysium. Individual muscle fibers then are surrounded by an endomysium, and the muscle fiber breaks down into the myofibril. We can see the myofibril here, and we've got our chain-like lengths called our sarcomeres. So each sarcomere is one of those little blocks dotted down along the myofibril. Okay. Just to recap, so the sliding filament theory. Okay, so again, I'm kind of recapping a little bit on. Let me just recapping a little bit from level 2. So the sliding filament theory states that when the myosin head nods, it pulls the ends of the sarcomere and actin together, causing a muscle contraction. Level 2, so I did level 2 last week, and I sent out a video on sliding filament theory. So I'm going to send you guys out that video as well. So if you've got any questions on sliding filament theory, which is level 2 stuff, and how a muscle actually contracts, I'm going to send that out to you. Okay. What I would advise as well is that you recap your level 2 stuff as well when we talk about muscle contractions, so concentric, eccentric, isometric, isotonic muscle contractions as well. Also looking at things like the skeletal system from level 2, and looking at joints, joint actions. So a lot of questions come up on the paper on joints and joint actions. So it's a lot of referring back to your level 2 stuff when we start to look at level 3. Okay, so when you come onto the level 3 PT course, we kind of assume that your level 2 knowledge is already up here. So we're just adding to it, okay? And we use a lot of that level 2 knowledge when we talk about muscles, muscle structure, joint actions, etc. Okay, so might be worth looking back over your level 2 stuff as well as what we're looking at here. Okay, so muscle fiber types. The muscle fiber types, again, this is kind of level 2, but we've got fast twitch and slow twitch muscle fibers. So our slow twitch fibers, first of all, are also known as type 1. They are slow oxidative fibers, which basically means that they're using oxygen slowly. They're red in color, contain large numbers of mitochondria, so our powerhouses that are bringing our energy to the working muscles, and also converting that oxygen into energy. Slow twitch muscle fibers are used for mainly endurance type activities. Fast twitch fibers, also known as type 2, are fast glycolytic fibers, so they use glycogen quickly. They are white in color, contain low numbers of mitochondria, and are used for strength anaerobic type activities. Okay, so the type 1 muscle fibers have been found to be the most aerobic in nature, with a greater blood supply and more mitochondria, and as a result respond well to aerobic low to moderate intensity training. Type 2 muscle fibers are very anaerobic in nature, with a reduced blood supply in comparison to the type 1 and much fewer mitochondria. Type 2 fibers respond well to high intensity exercise with higher force and power outputs. So when we start to think about the type of muscular strength endurance training that we're going to be doing with our clients, we're thinking about the amount of sets and reps that we're doing. Okay, so and also the weight that we're going to use as well. So if we want to work somebody's type 1 muscle fibers, we're looking at high repetitions, lighter weights. If we're looking at working somebody's type 2 muscle fibers, we're looking at more higher weights, lower repetitions. Okay, but also think about our type 2 muscle fibers when it looks at power output, explosive performance. So thinking about plyometric type exercises. Plyometric type exercises is where we're using explosive movements, power-based movements. So things like squat jumps, burpees, side-to-side lunges with, skaters. So where you're powering left and right, things like that. Okay. Any questions so far, guys, on what we've just looked at?
Oh, that's fine.
Okay. So what we're looking at now is our axis of movement and our planes of motion. So when we look at axis of movement, we've got 3 different axes of movement. So first of all, we've got the anterior posterior axis. This is where we've got something like a broom handle that goes into one part of the body. So as the picture shows, it's going in through the front of the spine and out through the back. When we rotate that axis, rotate that broom handle, we get a movement that occurs in the frontal plane. Okay, so in the frontal plane, where we're moving from side to side. So if I've got a broom handle that goes in through my shoulder, I don't know if you can see my video, guys. It goes in through the front of my shoulder and out through the back. If I take that broom handle and twist it, I get movement in the frontal plane of movement. So I'm getting shoulder abduction, shoulder adduction. So broom handle goes in to the front, out through the back, twist that broom handle from the anterior posterior axis, and I get movement in the frontal plane. Okay. Similarly, if I've got medial lateral axis, so this is where my broom handle is going in one side of the body and out through the other side. If I rotate that broom handle, I'm getting movement in the sagittal plane. Okay, so again, if we think about the shoulder joint, so my broom handle comes in through the side, out through the other side, so it's working across this way. If I then rotate that broom handle, I'm getting movement in the sagittal plane where my arm comes up in front and down in front. So I'm getting shoulder flexion, shoulder extension, okay, in the sagittal plane. The longitudinal axis then is where the broom handle goes down the top, from the top all the way down, and I get rotation. Okay, so I don't know if you can see that. So where the shoulder joint will rotate. Okay, and that is in the transverse plane. So each of these axes of movement will link up with the planes of movement. So we can see blue guy anterior posterior axis links up with blue guy frontal plane of movement. Medial lateral axis, yellow guy, maps into sagittal plane, yellow guy. And then the red guy, longitudinal axis, maps up with transverse plane. So, question for you. Anterior posterior axis. This is where, so I want to ask you a question. So let me think. So if I've got the anterior posterior axis going through the hip joint, what joint action can occur at the hip in the frontal plane? So think about broom handle going in through the front of the hip, out through the back of the hip. Movement is going to occur in the frontal plane of motion. What joint action can occur at the hip? Does everybody understand the question, first of all? I don't know if I've explained it quite well.
I'm guessing the leg adduction.
Yeah, so it's abduction, adduction of the hip. So if the broom handle goes in through the front, out to the back, and you rotate it, the leg will come out to the side and back down again to join up with the other leg. You've got abduction, adduction. Let's think about the elbow joint next. So elbow joint, if the broom handle is going through the medial lateral axis, so it's going in one side of the elbow and out to the other side of the elbow, movement occurs in the sagittal plane. What joint action occurs at the elbow?
So flexion and extension.
Exactly, yeah. So broom handle goes in one side, out to the other side. Rotate that broom handle in the sagittal plane, it's flexion, extension of the elbow joint. And then finally, longitudinal axis. So if goes down through the spine, okay, so broom handle goes down through the spine, occurs in the transverse plane. What joint movement occurs within the spine through the longitudinal axis transverse plane?
Rotation.
Rotation, exactly. So rotating right, rotating left, broom handle at the top, we twist it and rotation occurs. Okay, so we can look at each joint action and we can then determine which axis of movement it occurs in and which plane of movement it also occurs in. Okay, so a way to kind of practice this for you guys would be, once you do get back into the gym and you're doing different exercises, think about what plane of movement you're actually working in. Okay, am I working in sagittal plane, forwards, backwards? Am I working in frontal plane, side to side? Or am I working in transverse plane with rotation? There may be multiple planes that you're performing your exercise in. So if you've got a complicated exercise where you've got multiple joint actions and multiple movements, multiple planes, you will be hitting different axes of movement as well. Okay, Odette, just a quick one. I've just seen your message, type 2A muscle fibers. I'm going to come on to those in a little while. Okay. So axis of movement, anterior, posterior, medial, lateral axis, and longitudinal axis. Our planes of movement then are our frontal plane, sagittal plane, and transverse plane. Okay, so exercise. If I'm doing a squat, which plane of movement does a squat occur in? Anybody?
It's sagittal plane.
Sagittal plane, yep. So if we think about the joint actions that occur in a squat, where we've got hip flexion and extension, knee flexion and extension, and ankle plantar flexion and dorsiflexion, it all occurs in the sagittal plane, forwards, backwards movement. If I do a lateral raise exercise, so a lat raise exercise, what plane of movement am I working in?
Is it frontal?
Frontal plane, yeah. So the arms are coming out to the side, so side to side movement and back down again. So it's frontal plane. And then finally, easy one, Russian twist. So if I'm on the floor with a medicine ball doing Russian twists, which plane?
Transverse plane.
Yeah, transverse.
Yeah. Rotation, transverse plane. Okay. So 3 simple exercises where you can really see exactly which plane of movement you're working in. Okay. Now, us as personal trainers, we are going to try and make our training sessions more interesting for our clients. Okay, so what we should try to do is to incorporate different planes of motion within different exercises. So rather than just keeping it simple, lateral raises, a bit boring, maybe try to add in something where we would do sagittal and frontal plane. So can anybody give me any examples of any exercises or movements where you could incorporate 2 or maybe even 3 planes of movement?
A lunge with a twist.
Lunge with a twist, perfect. So you're doing sagittal plane with a lunge, and then as you add the twist in, you're using transverse plane as well. So we're challenging the body, we're challenging those motor skills as well as working muscular strength endurance within that type of exercise. So we do the lunge and then we add in the rotation. So what that rotation does is maybe takes the client off balance. There's more coordination that they've got to work on as well to be able to maintain a good technique to do that type of exercise. Good one. Anything else? Any other examples, guys?
Squat.
With a raise.
Oh, sorry.
That's all right. Okay, let's look. Somebody said squat with a raise first. What type of raise?
Medicine ball over the head.
Okay, so let's think about it. So who is that? Sorry, I can't see who's talking.
It's me, Odette.
Okay, cool. Sorry, I haven't got my videos, so I can't see who's actually talking. Okay, so what I want you to do, Odette, is to stand up, pretend you've got a medicine ball in your hands, okay, and I want you to do a squat and raise a medicine ball above your head.
Yeah.
So, first of all, the squat is sagittal plane, okay, forwards, backwards. Have you got any movement side to side with your arms
No.
or legs?
No, it needs to be a side raise. Yeah.
Yeah. So what I'm just getting at, so you've got no rotation either. So it's a really good exercise because it's a total body exercise. You're working upper and lower, and it would challenge the individual more than just doing squats. But both of those kind of movements, squat and the overhead raise, are both in the sagittal plane. So as you said, maybe adding in a side raise, so squat, and then as you come up out of the squat, bring dumbbells up to the side. You're doing frontal and sagittal plane. Okay. It's difficult to think about it without doing it. So I'm sure if you were doing that, you'd kind of figure it out. But then if you add in a side raise with that squat, then you're bringing in the frontal and sagittal plane. If you did with the squat with the raise up, so squat, and as you bring the medicine ball up above your head, add a twist in, and then back down, you're then bringing in the transverse plane with the sagittal. So you can just tweak that exercise slightly, and then you're bringing in an extra plane of movement as well. Is that okay?
Yeah.
Did somebody else say something then as well? Squat with something else.
I said squat with a plate hold in front of you.
So that's a similar sort of thing that we've just been talking about. Instead of the medicine ball, you're using a plate. So again, it's both sagittal. So you'd need to maybe add a twist in with that, or take something out to the side. Make sense?
So is that even if you're holding the plate in front of you, not necessarily above you?
Because it's in front, it's
Yeah.
still sagittal plane. So this would be sagittal plane, whereas this would be frontal plane.
Okay, that makes sense.
Yeah, sure.
Yeah, that makes sense.
Cool.
Thank you.
Frontal bit is the confusing bit because the frontal bit to me is the bit because
Yeah, because
you're saying that's the
that looks
frontal
like it in
plane,
front.
but you're going
Yeah.
to the side.
Yeah.
But
So I
yeah,
put my hands in
it does
front,
make sense.
but it's actually sagittal plane. The way I think about it is, this is frontal plane, something moving in front of you, something, front, so it goes side to side. I don't know if that makes any sense. It's just the way I tended to figure it out. So frontal plane, it kind of goes across side to side like that. Anyway, okay. So what I would say to you guys is, again, a way to kind of practice it is do a workout, and then think about your workout. Have I got multi-planar movements, frontal, sagittal, and transverse planes in my workout, or am I more sagittal dominant in my workout through all the exercises that you're doing? So then when you start to program for your clients, what we're trying to do is to bring in more multi-planar movements, and then have a balance throughout the whole workout that we've got all three planes of movement. This will also help with functional performance, not just with, what their goals are. So if we think about our cardiovascular exercise, bike, treadmill, rower, cross trainer, those stepper, those 5 are all sagittal plane. So running is sagittal plane, cycling is sagittal plane, rowing is sagittal plane, cross trainer, stepper. So if you've got somebody who does lots and lots of cardiovascular work, it's all sagittal plane of movement. So we need to then think about, when we're doing our resistance training, that we try to involve more frontal and more transverse planes. Make sense?
Yeah.
Yeah.
Yeah, thank you.
Cool. Okay. Quite interesting when you start to work with clients and then think about, actually, let me break down my exercises. I'm kind of more sagittal plane dominant in these exercises that I prescribe for my client. I need to then start to think about bringing in some more frontal, transverse, etc. Okay, going to move it on. If you are confused by any of this, or you want me to pick up with you one-to-one, just give me a shout and I can arrange a call with you. We can go through it in a bit more detail if you want. Okay, so it is quite a lot to take on board, and plus it's through a laptop as well, which is not ideal. Okay, so when we work with a weight loss client, skeletal muscle mass decreases during weight loss from dietary restriction, which reduces muscle strength and resting metabolic rate. So if somebody wants to lose weight and all they do is look at their nutrition, they don't do any activity, it means that they are going to reduce their muscle mass as well, okay, and muscle strength. So if they just do dietary restriction, they're going to lose muscular strength and muscle mass. Your body shouldn't naturally go for muscle first in weight loss if you're doing it correctly. In general, muscle is not lost before fat. It is very dependent on nutrition and activity volume. A person who is attempting to lose weight by not eating may lose weight in muscle first before fat. So it's important that somebody who wants to lose weight does activity as well as look at their nutrition. The resistance training for weight loss guidelines. Frequency, 3 to 6 times per week, resistance training. Now, when we talk about resistance training, it's not all about pushing weights. Okay, so things like body weight exercise, weight bearing exercise will help with resistance training as well. So it doesn't have to be about pushing dumbbells, etc. Resistance bands are a really good way to work resistance training as well. Okay, so 3 to 6 times per week. Intensity, 60 to 80% of 1 rep max, working 3 to 5 sets. Now, that will depend on whether we're working endurance or whether we're working strength on that continuum that we looked at on Principles of Exercise Level 2. Time, 45 minutes to an hour per session. And then the type, full body compound movements, weight bearing using systems such as pyramids, supersets, trisets, and giant sets. Okay, so full body compound movements. What's a compound movement?
Where you use more than one joint to do a movement.
Yeah, more than one joint. So a bicep curl is just one joint, so that's an isolation exercise. What we're looking to do is to get multiple joint actions involved with our exercises. Weight bearing, what does weight bearing mean?
Using weight
Yeah,
as the resistance.
Yeah, so what we mean, a squat would be a weight bearing exercise. Yeah, perfect example. So you do the exercise holding your whole body weight. So if I were to do a bicep curl, me at the moment doing a bicep curl is non-weight bearing because I'm sat down. Okay, so I'm not holding my whole body weight. If I do a standing bicep curl, it's weight bearing because I'm holding my whole body weight. I have to control my whole body weight to perform the exercise correctly. Walking is a weight bearing exercise. Running is weight bearing exercise. Cycling is non-weight bearing. Rowing is non-weight bearing because you're sat on your backside. Okay, swimming is non-weight bearing. Okay, so we're trying to incorporate as much weight bearing exercise as we can. And using systems such as pyramid training, supersets, trisets, giant sets. Okay, so with these training systems, the link that I'm sending out to you this afternoon for those videos has got examples of pyramids, supersets, trisets, giants on those. Is that okay? Any questions so far? Okay, so weight loss clients still. So although a weight training workout doesn't typically burn as many calories as a cardio workout, it has other important benefits. For example, weight training is more effective than cardio at building muscle, and including fat. Because of this, it is commonly said that building muscle is the key to increasing your resting metabolism, your basal metabolic rate, the amount of calories burned at rest. By increasing that, you're going to burn more calories, burn more fat. One study measured participants' resting metabolism during 24 weeks of weight training. In men, weight training led to a 9% increase in resting metabolism. The effects in women were smaller, with an increase of almost 4%. So the basal metabolic rate in men went up by 9%, and in women went up by 4% by doing weight training. While this may sound good, it's important to think about how many calories this represents. For the men, resting metabolism increased by about 140 calories per day. In women, it was only about 50 calories per day. Any questions on that? Or do you want to recap it? Okay. So a muscular strength. So that was kind of looking at weight loss clients. We're going to move on to a muscular strength endurance client now. Any questions on what we've done so far? So hypertrophy clients. So a client who wants to build muscle mass. So when you start exercising a muscle, first, there's an increase in the nerve impulses that cause muscle contraction. The message being sent from central nervous system down peripheral nervous system to the motor unit. Okay, so there's an increase in the nerve impulses. The message is being sent back and forwards that cause muscle contraction. This alone often results in strength gains without any noticeable change in muscle size. So you may notice that the strength goes up first before the size of the muscle. As you continue to exercise, there is a complex interaction of nervous system responses that result in an increase in protein synthesis. Over months, the muscle cells begin to grow larger and stronger. There are two essential components necessary for the growth of muscles: stimulation, first of all, and the repair. So the stimulation This occurs during the contraction of the muscle, during the actual exercise. So each time a muscle is exercised, it contracts. This repeated contraction during a workout causes damage to the internal muscle fibers. These muscle fibers are broken down throughout the course of a workout. Once damaged, these fibers are then ready to be repaired. So muscle fiber repair occurs after the workout, while the muscles are resting. New muscle fibers are produced to help replace and repair the damaged ones. More fibers are produced to make up for the damaged ones, and this is where the actual muscle growth takes place. Okay, so this is why recovery and rest is really, really important when it comes to hypertrophy training. It's also one of the reasons why we do split routines. So on a Monday, for example, they may do chest and shoulders. On a Wednesday, back and arms. On a Friday, legs, and then maybe just a whole body workout on the weekend with lighter weights. So it allows the muscles to repair in between sessions. Okay, so during the exercise, it's about stimulating and damaging those muscle fibers. And then in the recovery period is where those muscle fibers will repair, producing new muscle fibers bigger and stronger. Any questions? Okay. Increasing strength. So strength clients, strength is both a function of mass and the amount of neurological patterning of the muscle fiber. The neural adaptation, first of all. Okay. Strength training develops motor neuron pathways that enhance an individual's brain-body coordination during functional movements. The neural adaptations individuals undergo in training refers to the brain's ability to recruit muscles to contract and produce a particular movement. Practicing an exercise with resistance teaches the individual's brain to fire the correct muscles to achieve a desired motion. Over time, the athlete's technique to the exercise becomes ingrained and the movement becomes more automatic. Okay, so recap that. If we think back to our level 2 nervous system, and we're looking at muscle fiber recruitment, motor unit recruitment. The central nervous system will see an object or a weight on the floor. It will make an assessment as to how many muscle fibers or motor units need to be recruited to lift that weight. Okay. The body then will produce the force that has been told to produce, okay, and will lift that weight. The more you lift that weight, the efficiency of the nervous system to lift that weight will improve. So over time, the nervous system will then be saying, okay, we need to produce 80% of our motor units to lift this weight. So what we will then do is over time, that will become automatic. And then the nervous system will just click in and go, right, recruit these guys. We know what we're doing here. We need to use this amount of muscle fibers to lift that weight. What we will then do is we will challenge that. So we'll add weight to the bar, make it heavier. So even though we know there's more weight, our nervous system still is not able to process how much we actually need to lift. We need to fire to lift. So with an increased weight, our nervous system is then going to respond to that increased weight. Okay, we need to recruit more and more muscle fibers to lift this weight. So more motor units, more muscle fibers. We're now up to 85% of muscle fibers to lift this weight. So it's a neural adaptation, nervous system response. Over time, so we can see in the last sentence, over time, the athlete's technique to the exercise becomes ingrained. So technique is perfect and the movement becomes more automatic. We don't have to think about it as much. So we need to challenge it again, add more weight. So technique is tested and the movement is not as automatic as it was. But again, with more practice, the technique improves and the movement becomes more automatic due to the neural adaptation, nervous system response. Does that make sense? Say no if it doesn't.
Yes.
Okay. person. Okay.
Yeah.
So, okay. So with hypertrophy, having bigger muscle fiber doesn't necessarily mean greater force production. But if you combine that with neural adaptation, it will provide greater strength gains. So just because somebody has got big muscle mass doesn't mean necessarily that they are strong. Okay. However, if we combine that muscle mass with the neural adaptation, you will get bigger strength gains. Okay. So we're going to move from strength to endurance. So when we increase endurance, so muscular endurance is the ability of a muscle, a group of muscles, to perform repetitive contractions against a force for an extended period of time. The greater your muscular endurance, the higher number of repetitions you could complete. So training muscles for endurance will develop type 1 muscle fibers as opposed to type 2 during strength and hypertrophy workouts. Endurance training builds the energy systems of the body, the muscle fibers and capillaries that can sustain long periods of exercise, such as running a marathon or cycling a 100-miler. Guys, can you just check that you're on mute? Please, I've got a lot of background noise going on at the moment. Sorry. Cool. Perfect. Thanks. Okay, so I'm just going to jump back to the sentence that says, training muscles for endurance will develop type 1 muscle fibers as opposed to type 2 during strength or hypertrophy workouts. So when we work strength hypertrophy, we're working type 2 muscle fibers. When we work endurance, we're working type 1 muscle fibers. Now, as Odette has pointed out, you've also got type 2A muscle fibers. These are your hybrids. Your genetics will basically say that you are predominantly type 1 or predominantly type 2. You tend to be more of one than the other. If you've got a 50-50 split, you're one of the lucky ones. Okay, but you sitting there now, you can basically say, okay, I'm more of a sprinter or I'm more of a long distance runner. Okay, so I'm better at short, sharp, or I'm better at longer. So you can kind of see, okay, I'm more of a type 1 muscle fiber person or I'm more of a type 2 muscle fiber. Does that make sense? So you can kind of put yourself in that little bit of a category. Now, the type 2A muscle fibers, your hybrids, are the ones that you can develop either way. So if I've got an endurance athlete who has got obviously lots and lots of type 1 muscle fibers, he's got a certain amount of type 2. His type 2As, I can develop down the type 1 line. So it means that I can basically develop more type 1 muscle fibers for him to be able to do his endurance work more efficiently. If I've got a power lifter, for example, they are predominantly type 2 muscle fibers. His hybrids, I'm probably going to train down the type 2 line to give him more of that explosive and strength that he needs to perform his workout. I'm not going to put those down the type 1 side because there'll be a little bit of a waste because we need to push as many type 2s as we can. So the type 2As, the hybrids, are the ones that we can develop either way. Any questions on that? Odette, does that kind of, I know you didn't really have a question on it, but does that?
So can you develop a type 1 to have the type 2A as well?
No. So
so it's predominantly the type 2s that develop the type 2A.
Say that again, sorry. Yeah.
But it's like Mo Farah couldn't become a Usain Bolt.
Probably not. No, because he wouldn't have enough hybrids to change him from a marathon runner to a sprinter. We could train for Mo Farah for years and years and years and years, but he'll never be a good sprinter. You know what I mean? He's got that kick to finish a long distance race, but it's not enough to win a 100-meter sprint. You know what I mean? If we look, I might have mentioned Usain Bolt to you on the course. Usain Bolt is a bit of a freak because he looks like an endurance runner, but because his muscle fiber types, so Usain Bolt started out as like an 800, 400-meter runner. So they were kind of training his muscle fibers down more the type 1 side. But then they noticed that looking at his technique, etc., he had a certain amount of type 2 muscle fibers. He was kind of one of those freaks who kind of nearly had a 50-50 split with type 1s and type 2s. So with his hybrids, instead of training him down the type 1 side for his 400, 800s, they then decided to go, right, let's push him towards more his type 2s and let's see how he gets on as a sprinter. So changed him to the 100 meters and 200 meters, and the rest is history. But yeah, he's a bit of a freak because he was good at both on that. But yeah, with Mo Farah style, so me, for example, I'm long distance. I do long distance. I'm rubbish at short sharp, so I play like Gaelic football as well. So what I struggled with was the short sharp stuff. I could like last the whole game no problem, which is like just over an hour and 10 minutes is a Gaelic football match. So to last the full length of the match was no problem to me. However, if I had to chase somebody from one side of the field to the other in a sprint race, I would struggle. So I was trying to develop my type 2s to improve that side of things, but I was predominantly type 1. So I can kind of look at a client. So if I've got a client who is a team sports, I can kind of say, right, they're able to last the whole game, no problem. So maybe we need to look at their type 2s on the explosive side a little bit more, or where they have got really good type 2s, but they can't last the whole game, then we'd maybe look at their type 1s. Does that make sense? I don't know if I'm explaining this.
Yes, it does.
Cool. Okay.
Yeah, thank you.
So this is where it becomes interesting with your sports performance clients, where you've got people who play team sports, different types of testing you can do. You can kind of see, right, we need to work on their type 1s, type 2. Rugby is a good example. Who were the first people, if anybody watches rugby, that is, hopefully some of you do, but if you watch rugby, who tends to be the first players that are substituted in a rugby match? Anybody?
The big guys.
The big guys, exactly. Yeah, you did right. The front row, okay, those big guys, type 2 guys, type 2 muscle fibers, they're all power, they're all explosive because they can't last the full length of the game. So their job is done after about 60 minutes, maybe even before that. 50, 60 minutes, their job is done. They're spent. They've got nothing left because they're predominantly type 2 muscle fibers. Whereas most of the other players, like the backs, so wingers, scrum half, fly half, things like that, they tend to be more type 1, where they run and run and run and run and can last the whole length of the game. But your front row guys, they're spent after about 50, 60 minutes. Okay. Right. I'll move on. If you've got any other questions on that, guys, I find it really, really interesting when I work with different clients to try and figure out which side they are and what to develop. It is a quite interesting thing. Okay. So the muscular strength endurance client. So we need to look at our clients and we need to look at, right, are we going to look at the strength side of things, or are we going to look at the endurance side of things, or are we going to go a little bit in between? Okay. So if we're looking purely on strength, we're looking at high intensity exercise, really high resistance, high weights. So we're looking at weights that are greater than 75% of 1 rep max. We're also working with low repetitions, so between 1 and 10. So if we're working at pure strength, we're probably working about maybe 3 to 5 repetitions. For muscular endurance, we're looking at low to moderate intensity, low to moderate resistance, so low weights. So you're looking down 40 to 60% of 1 rep max. So we're looking high repetitions, 15 to 25. If we're looking at hypertrophy training, you're probably looking at more the strength end of things, but you're looking at repetitions of 6 to 8 repetitions, maybe up to 10 repetitions, something like that. So for strength, it's really, really heavy weights, low reps. For hypertrophy, again, it's heavy, but you're looking at more around the 8 repetition mark. And then for endurance, you're looking at resistance training exercise between 15 and maybe up to 25 repetitions. Okay, but obviously you can go in between as well, and you can mix the two. We want to build a little bit of strength, but we want to keep our endurance going as well. So again, that's a judgment call you need to take with your client. For sports performance then, so when developing the muscular system for sports performance, you will need to research the type of athlete and sport. The client will require a program tailored to their sports requirements, such as endurance, strength, power, hypertrophy, flexibility, and motor fitness. Along with muscle building and fat burning, resistance training also improves upon a person's posture and helps to strengthen your bones. As a result of this, the likelihood of an injury among athletes, as well as the severity of the injury itself, is greatly reduced. In the case of an injury, however, the healing process can also be faster. So benefits of resistance training for sports performance: reduces the incidence or severity of injury, improvements in overall flexibility, healthy, efficient body composition, increased resting metabolism, increased power, and increased bone mineral density. Any questions so far, guys?
No, that's fine.
Cool. Right, so what I've got for you next are all of the muscles that you need to know for level 3. So I'm sending these slides out to you in a little while. So I'm not going to read all these slides to you, okay, but I am going to focus on one or two others. So we'll see the difference between level 2 muscle knowledge and level 3 muscle knowledge jumps. You need to know more muscles for level 3, okay? So biceps and triceps, brachialis, deltoid, okay, rotator cuff. So the 4 muscles of the rotator cuff you need to know. So what we've got here is infraspinatus, supraspinatus, and teres minor all sit on the posterior of the scapula, okay, on the back of the scapula. The subscapularis, as you can see in the bottom right-hand corner, is viewed from the anterior, so it sits on the front of the scapula. Okay. So it's important to know that there are 4 different rotator cuff muscles. Infraspinatus, supraspinatus, and teres minor and subscapularis are the 4 rotator cuffs. So you may have a client who comes in and says, I've damaged my rotator cuff. Your next question should be which one, okay, or how many of them have you damaged, okay? So because it will depend on different movements. So you'll see people, and you will see people in the gym when they're doing this type of movement with a cable or a dumbbell, and they're doing this type of movement with a cable or a dumbbell, which is working rotator cuff. But we need to look at, so if I work, if you can see me, if I work internal rotation, okay, I'm going to work subscapularis. If I'm working external rotation, I'm going to work teres minor, supraspinatus, and infraspinatus. So I need to think about which rotator cuff muscle is actually damaged or which needs to be strengthened to decide which type of movement I need to do. So rather than just prescribing for your client internal rotation, external rotation, or rotation up here to improve rotator cuff, we need to think about which aspect of rotator cuff we need to strengthen. If it's an all-round, then obviously we do both. Okay, but if there's damage there, we need to find out what damage has occurred to which one so we don't make it worse. Okay. Latissimus dorsi, pectoralis major, okay, freaks me out. Serratus anterior. Okay, so serratus anterior is another one of those muscles that adds on from our level 2 stuff. So origin, fleshy slips from the outer surface of upper 8 or 9 ribs, and the insertion is onto the costal aspect of the medial margin of the scapula. Basically, it starts on the top ribs, and then it spreads across the ribs and inserts onto the scapula. Its function, it protracts and stabilizes the scapula. So when you do protraction, the scapula will open up and the shoulders will round forwards. When you do retraction, you bring the shoulder blades together. So the serratus anterior will help that movement, but also help to stabilize the scapula when you do certain exercises. So when you do a chest press, for example, we don't want the scapula opening up and closing as we do our chest press movement. We don't want any of this. So the serratus anterior will help to maintain that posture and stabilize the scapula in that sort of movement. Trapezius, so as we can see with the trapezius, big kite on the back. Rhomboids in between the shoulder blades. Erector spinae. Okay, so erector spinae is what we looked at on level 2, but now we're splitting our erector spinae into the 3 muscles that make it up. So we've got spinalis. We can see with spinalis, it runs really close to the spine. Longissimus comes out a little bit from the spine, and iliocostalis comes out a little bit further. So we can see with the actions of all 3 on the bottom of each of the descriptions. The actions are lateral flexion of the neck, okay, and it will help, and it will extend the vertebral column. Okay, so the erector spinae, its main function is spinal extension, but it will also help with lateral flexion of the neck. Okay? Spinalis, longissimus, and iliocostalis. Multifidus is also a muscle that runs up along the spine. However, with the multifidus, if we look at the action, it's extension and rotation of the vertebral column. With the extension, it allows the spine to extend vertebrae by vertebrae. Okay? Whereas the erector spinae muscles will extend the vertebral column, the multifidus will allow you to do it vertebrae by vertebrae. Okay? So we can see the origin is posterior superior iliac spine, transverse processes of lumbar-thoracic and C4 to 7 vertebrae. The insertions, spinous process of the second and fourth vertebrae above each origin. So as we work up along the spine, what this is basically saying is you've got origin, insertion, origin, insertion, origin, insertion, origin, insertion as it maps up along the spine. But kind of like lots and lots of separate muscles as it moves up along the spine. Does that make sense?
I'm a little bit confused on that one. Would you just explaining that again? Sorry, if you don't mind.
No, that's absolutely fine. Absolutely fine. So what we need to think about here is the difference between erector spinae muscles. So what erector spinae muscles do, I don't know if you can see my hand, but what I'm looking at here, so this is my spine. So erector spinae, so as the spine is flexed, what erector spinae does is it extends the spine in one movement. The multifidus will extend the spine vertebrae by vertebrae. So the origin, let me go back, origins of all three erector spinae muscles are origin at the bottom, insertion at the top. With the multifidus, we kind of have origin, insertion, origin, insertion, origin, insertion as it works its way up along the spine. So it's like lots and lots of different muscles up along the spine, as opposed to erector spinae, which is one big long muscle. Does that make sense?
Yes, that's really good. Thank you.
Sure. Okay, cool. Quadratus lumborum, really important part of the core stability muscles, quadratus lumborum, where, as we can see, we've got one on either side, obviously. So if you've got scoliosis, what we tend to have here is one side is tight and one side is weak. So we cause that lateral tilt in the spine. Okay, so really important muscles that it's important to keep these two balanced as much as we can, rather than one being stronger than the other. So if we think about if you've got kids and you hold a child on one hip all the time, what you're causing here is an imbalance. So if I'm holding the child on my right hip, then my right side of my QL is longer and my left side is shorter. So over time, you're creating an imbalance and a potential scoliosis of the spine there. Okay, so these are important muscles that we need to work on. So things like side planks are a really good way of strengthening quadratus lumborum. Transverse abdominis is that belt right in deep in the core area of the body. So they are constantly contracting and relaxing. Okay, no matter what you're doing, your transverse abdominis is always switching on and off with whatever movement you're doing. It's all about stabilization of the lumbar section of the spine. Rectus abdominis, 8-pack. Erector spinae, just quick recap on that. I'll take that one out actually. External obliques, internal obliques. Pelvic floor muscles. So these are important. Questions come up on the paper on the pelvic floor muscles. So situated under the pelvis, a double layered muscle consisting of a deep and superficial layer of muscle tissue and connective tissue provides stability for the pelvic girdle, controls organs and growing fetus in pregnancy, and also controls continence. So questions come up on the paper on the function of the pelvic floor muscles. Then moving into the legs, we've split our hip flexors, iliopsoas, into psoas major and iliacus. Our gluteals, gluteus maximus, gluteus minimus, and gluteus medius, I should say. Change that. Okay. Piriformis, so this is an important muscle as well. So the piriformis, as we can see where it attaches from the sacrum out to the top of the femur, if that muscle is tight, it will lock our ball into the socket. So we need to make sure we can do exercises to release this. So by releasing it, just allows that free movement of the hip joint. Our adductor muscles are split into adductor longus, magnus, and brevis. Pectineus muscle, it is an adductor muscle, so adduction, but also causes hip flexion. Gracilis sits down the inside of the thigh, so adduction of the hip, but also will help with flexion of the knee. The sartorius starts on the outside of the hip, and then crosses the hip joint onto the inside, onto the medial side, and runs down the inside of the leg and sits below the knee. Tensor fasciolate, so sits on the outside of the hip. So your TFL is the muscle part, and then that will move into the IT band, iliotibial band. The ilium, bone at the top, tibia, bone on the shin, so iliotibial band. So the TFL is the muscular section of it, right on the hip, and then it moves into the IT band. Hamstrings, biceps femoris, semitendinosus, semimembranosus. So all three hamstrings cross the hip and the knee joint. So that's why you feel the hamstrings when you do deadlifts, because they help with hip extension. Main function is knee flexion, but they help with hip extension. Quadriceps, there are 4 of them. So rectus femoris crosses the hip and the knee. Vastus intermedius, vastus lateralis, and vastus medialis cross only the knee joint. So main function is knee extension, but the rectus femoris will also help with hip flexion. Gastrocnemius and soleus are your calf muscles. Gastrocnemius crosses knee and ankle. Soleus crosses only the ankle. And finally, tibialis anterior, so at the front of the shin, and it causes dorsiflexion. Any question? I've gone through that really quickly, guys. In your manuals, you've got a list of all of these muscles. It will tell you the location of the muscle. It will also tell you its origin, its insertion, and the action that it causes. Okay, but there's no diagrams, no photos of them. So that's why I put all these together for you, so you can actually physically see where they are. So if you've been on a course with me already, you may have done the sticky labels. So this is a really good way of learning the location of the muscles, okay, because you've got more to learn now. So what you do is get some sticky labels, see if you've got somebody at home who can stand there for half an hour, put a muscle on an individual sticky label, and then stick it to the person, as in the location. So try to do as many as you can without looking at your manual or without looking at the diagrams, and see what you know. Then take them all off, go again. Keep doing it as much as you can until you are able to locate all of the muscles of the body. And I find that that's a really good way to learn the location of all of these muscles. Okay, you can see now the difference between level 2 and level 3. It's quite a step up when it comes to different types of muscles. So rather than just looking at the hamstrings now, we're trying to split them down into the 3. Rather than looking at just the quadriceps, we're splitting them down into the 4. Okay, we're looking at what those 4 muscles will do as well. So all 4 of them cross the knee joint, but only one of them crosses the hip joint. So we need to look at that effect that that would have on hip flexion. Okay, so we're really taking it into detail. As I said yesterday, so any of you who weren't on yesterday, what we normally do with these sessions is we're doing them in a classroom. So I'm hoping to get back into the classroom in January, February time. Fingers crossed. Who knows what can happen between now and then. So we're hoping to set up sessions. So some of you were with me in D-side back in March. So I'm hoping to obviously jump back in January, February. I know it's nearly a year down the line, but we are hoping to get back into the classroom to help you guys with this stuff, to prepare you for the practical side of things. So with these sessions, we're mainly looking at the theory side, but we are trying to push back into doing the practical side of things as well. I'm going to send you out that link for all of the resistance training systems that we do. Hopefully some of that might help with some of this as well. Has anybody got any questions on anything that we've done either in this morning session or the session we've just done now? No. Okay, so guys, I shall leave it there for now. Okay, guys, can you hear me? Anybody got any questions or anything?
If we do have questions later on, can we just email you?
Of course, yeah, no
Yeah.
problem at all.
Brilliant. Thank you.
Sometimes it might be easier as well if you want me to pick up the phone and give you a call. I can do that. So if sometimes it might be easier, but yeah, by all means, ping me an email, and then we can take it from there.
Brilliant. Thank you.
Cool, no worries.
Thank you.
Cheers. Thank you.
Right.